It's chapter 3. Chapter 3. Oh, I forgot to check the framing. Yeah, I got the whole board in the shot. Okay. Chapter 3. No, the reading is chapter 4. The problem we're doing right now is chapter 3. The clown problem is chapter 3. So this is chapter 3, number 45. So chapter 3, number 45. Get rid of this stuff. All right, now let's put it here. Chapter 3, number 45. Okay, I got the question here, and there's a whole bunch of information, and there's these two clowns being shot out of the air, okay? And we're supposed to find the initial speed and direction that one of the clowns is shot out of the air, but they give us the other speed and direction. Does that make sense? Okay? So I'm going to draw an awful picture here. You should have the actual question out to have a good picture. Yes? Yes? Okay, all right. So here's my awful picture. Here it goes. The clowns are going to just be these dots. There goes a clown, there goes a clown, and they're going to hit each other, okay? Now, when they hit each other, they are 1 meter, I think it's 1 meter above the ground. Is that correct? Is it 1 meter above? Yeah, 1 meter, not above the ground, sorry. 1 meter above where they're launched from, the muzzles of these people launchers. Yes, these cannons are being launched out of. All right. So there's two ways that could happen, okay? There's two times when this clown, let's say, when does this clown get hit by the other one? If he's going to get hit at 1 meter above the ground, there's two times that could happen. It could happen on the way up, or it could happen when he's on the way down. Now, to make our work a heck of a lot easier, okay, there's a condition that they placed on it. And the condition they placed is that the angle for this clown is greater than 45 degrees. So if this clown, and they're separated by some distance, if this clown was going to hit this guy on the way up, okay, and we have a solution greater than 45 and one that's less than 45, the one that's less than 45 would hit him on the way up. Does that make sense? So when we're looking for solutions, we're looking for the one that's later on in time. Is that still okay? All right. So I'm only going to solve then for the one solution that we care about. I know the key did more. That's not necessary if you can reason your way through which one's correct based on the given information. If it was a free response question, I might write a little sentence here about that. Okay? All right. So we're looking for that later time when they hit on the way down. So my picture is not quite right. They'd probably go up like this and then hit like, right in here somewhere. Are you okay that my picture is garbage? Is everybody else okay my picture's garbage but knows what's going on? Yes? Yes? Okay, all right. Oh, and if you're not following along, whenever I look around the room, just don't look at me, because otherwise I'm going to think you're following along. Yeah, just look at your screen. Okay. All right. So now let's go ahead and get some additional information on here. So clown, I'm going to. Did they give them? They called them clown A and clown B. Perfect. So this is clown A that's being launched from here, and this is clown B. So I'm going to write some information for clown A. Okay. So V naught for clown A. Can you tell me the number? What's the overall magnitude in the problem? 9 meters per second. All right. And what was our theta for that clown? What was our direction? 75 degrees? Okay, so 75 degrees. So they gave me enough to directly get V naught AX and V naught AY. So I can get the X initial velocity and the Y initial velocity for clown A. I don't know if I need it, but let's just assume that I do and take care of it now because it's components. Is that okay? All right, so this will be 9 meters per second cosine 75. Oh, I better check. Was that 75 degrees was that 75 degrees this right here? Yeah. Okay, so from the horizontal, so X will be cosine, Y will be sine. Is that okay? All right. So 9 cosine 75 and 9 meters per second sine of 75. And again, since I happen to know all the numbers, I'm just going to get those components now. Okay, and they'll both be positive. It's fired right and up. Does anybody that's watching happen to have these two numbers already calculated? I'll grab my calculator if not. Anybody happen to have them? No? Okay, I'll grab my calculator. All right, so 9 cosine 75. And I don't know if I'm going to need it, but probably I will. We're going to call it 2.33. And could somebody double check, make sure I haven't completely messed up? 2.33 was what I got. Got what you, okay. And then I'm going to go ahead and call this 8.7. Yes. Yeah. We're ignoring sig figs, I understand that. Also, I started with 1, right? Okay, all right. Did you need this problem? No. I was going to say, all we've done so far is eliminate half the problem. They hit when they're later on in time, because there's two solutions. One on the way up, and then one on the way down. You may do something else academic. You can do your physics reading if you haven't yet. The 4.1 through 4.6. Yeah, all right.
There's an easier one.
Okay, so the first thing I was going to say is that when we launched, we could hit here like way above, or we could hit when they're on the way down. Like we could hit when B is fired like this at a real shallow angle on the way up, or we could hit when they're on the way down. My horrible picture represents when they're on the way down. So this guy will be bigger than 45. So we're only going to solve this once. I've already ruled out half the problem, even though there's two solutions, based on the condition in the problem. Is that okay? Mm-hmm. Okay, all right. So we got that info. So there's our V naught X, V naught AX, V naught AY. Oh, and the initial velocity is the same as the final velocity. So just to emphasize that, I'm just going to say velocity of clown A in the X direction because it stays the same. Is that okay? All right. So now let me see what the heck else we know. All right. They're 6 meters apart. So I'm going to put that on the picture. They're 6 meters apart. And we're trying to get, again, we're trying to get back here to V naught, the magnitude of V naught B, and the angle for B. That's what we're trying to work our way back to, right? Okay. I know this is 6 meters. I'm also going to put on here, I'm going to go ahead and call this XA and call this XB. Is that okay? Okay, because they might not go the same distance in the X. We're good? And then now that I've drawn that on my picture, in case I need it, I'm going to go ahead and write XA plus, nope, that's too messy. I'm going to go ahead and write XA plus XB equals 6 meters. Just a thing I can write based on the word problem. Is that all right? Yep. Okay. Probably, I'm pretty sure I will need that. I'm not sure if I'll need both of these, but I'll definitely need that. Okay. So now let's see, what else did they tell us? I think that might be it. Yeah, we're going to need everything that we wrote down then, unless they told us something else. Yep, that's it. So we're trying to work our way back to here. So let's figure out stuff that connects clown A's launch to clown B's launch. Oh, there's one other piece of information that I left out. My displacement for both of these, we talked about it, in the y direction will be 1 meter. Is that okay for everybody? My displacement in the y for both of them will be 1 meter. That's the whole going up. Okay, all right. So we got to get some stuff to be able to solve for these initial conditions. So I want stuff that is linked between the two. So one thing for sure that's linked between the two, if they're fired at the same time, is that they'll hit each other at the same time. So I'm going to start and try to figure out at what time do they collide. Is that okay? Is that all right? Okay. So to do that, I'm going to go ahead and look at the y direction, because typically that's where I start for time. And I'm going to list my 5 variables in the y direction for clown A. We'll see where that gets us. Okay. So I'm going to just note that this is for clown A, so that I can just write y minus y naught and not have to put a's on, although it's the same displacement. So yeah, I guess we're okay either way. So v naught a in the y direction, acceleration in the y direction, v final of a in the y direction, and time. I'm going to try to fill out 3. Displacement is 1 meter, positive 1 meter. I am calling up and right positive, standard stuff. So positive. I'm assuming free fall. Is that okay? This is after they've launched. They don't have any jetpacks or anything. They're like Mario Ball. They're flying through the air. So my acceleration will be negative 9.8 meters per second squared. I know V naught A is 8.7. Oh, good, good, good. So we have enough to directly solve for time. I can pick an equation and solve for time right away. I'm going to go ahead and do that because that's something that links. They both hit each other at the same moment in time. So that'll get me the time for B. If it's the time for A, it's the time for B. That it's in the air. Is that good? Yes. All right, so we're getting somewhere. So let me go ahead and pick an equation and solve. So y minus y naught equals v naught t plus 1/2 a t squared. And these are all, this is actually v naught ay if I want to be consistent with my notation. Okay? I did not put a's on this or this because that's going to be the same for everything in this problem. Right? The displacement of the y is the same for clown B as it is clown A. Or you could always just put clown A here if you didn't want to have all the a's on everything if they were different. And let's plug in. So I'll have 1 meter equals v naught a, which is 8.7 meters per second, times t. I'm going to go ahead and do the 1/2 times negative 9.8 in my head and write negative 4.9 meters per second squared times t squared. I think that is also fine for the AP test. Do that in your head. You're going to know what the grader will be able to figure out what you did. We good with that? All right. So now, solving this for t, you'd have negative 4.9x squared on your graphing calculator plus 8.7x minus 1 equals 0. Do you have any idea what I'm talking about? Yeah. Okay, good. So let's go ahead and get our 2 solutions for t. Do one of you have it? If not, I'm just going to grab the key. Does somebody have it already solved, the graph? The both solutions. I'll just grab the key. Because I know you guys can do the quadratic formula or graph it. All right, let's see what they got. They got 0.123 0.17, so we'll just call it 0.12 or 1.65.
There it is.
0.12 or 1.65. But there are two solutions, and they both have a physical meaning. There's 2 times when this is 1 meter above the ground. But we're neglecting the one where this guy is fired at a really low angle. They did that just so you wouldn't have to do the whole problem twice. Okay? Which means we don't need that one. Are you okay with me getting rid of the 0.12? So when we hit 1 meter above the ground, when this one's launched at greater than 45 degrees, okay, a lot of statements here, it'll be at 1.65 seconds. You sure you're still with me?
Yeah.
All right, I'm going to pause there for a minute, give you guys a chance to look and see if you got a question before we continue on and start to look at clown B a little bit and see where we get stuck. Where do we have questions? We're obviously not done yet. We're not even close to done, but we're getting there. Going once, going twice. Sold. Yeah, go ahead. Yes, go ahead. Just have your ID on you. Yep. All right. Other questions? Oh, that's an important one. All right. So now let's go ahead and look at clown B. And there's lots of ways to do this. Okay. I'm just going to, since I know something for clown B now, I'm probably going to get stuck. But I'm going to list my 5 variables for clown B in the y direction. Because if I'm trying to get my V naught B, I'm going to want to get the x and the y parts and then put it back together. Does that make sense? Yeah. Okay. So I'm really looking for V naught BX and V naught BY, and then I can solve for these 2 things. Is that good? Is that good for everybody else? I'm trying to find the components that this thing's launched at, because we got to treat the x and the y separately for motion, and then I can find these 2 once I have the components. Okay? All right, so I'm going to go ahead and look at the y direction because I happen to know time now, and I'm going to list it for clown B. So y minus y naught, acceleration of the y, initial velocity, how am I writing this? Initial velocity, clown B, y, time, and v final, clown B, y. All right, and we got the time, because the time is shared. So 1.65 seconds. We've got the acceleration. Oh, this is good. We've got the acceleration because we're in free fall. And we have the displacement because they both hit at the same point above. So we can actually already find both of these? No. That's not right. I did something wrong. Yes, but we don't care about one of these. Never mind. They asked us for the initial conditions, not anything about the final. We're good. I was like, it can't be that easy. All right. So we don't care about this one, but we can absolutely now solve for this one. So we're partway there. Okay. So in the y direction, I just need to pick an equation and solve. I'm just going to go ahead and leave that there for a minute and not solve it yet and just know that I can. Is that okay?
Yes.
All right. Because we also need to get the x component. Okay. And in the x direction, both of these are the same idea if they're in free fall. The acceleration of the x is 0. The acceleration of the x is 0, okay? So I'm going to go ahead and just write the only thing that matters. And I'll go ahead and put here that this is for clown B, just to keep it clear. X minus x naught equals, and I'm just going to write, I'll write V naught, because I got the V naught there, but I could just write V. V naught BX times T. And I know T, right? But I don't know X minus x naught. I've got an equation up here that has to do with it, like with XB. I'm going to change this to XB now. So I'm obviously going to have to do something with that to get XB. Does that make sense? All right, so let's go ahead and deal with that. So this equation right here, I'm just going to rewrite it. So XA plus XB equals 6. And I need to solve for XB. So I need an equation for XA. Are you with me?
Yep.
So I'm going to go back here to clown A. I'm just going to squeeze this in right here for clown A. And I'm just going to write XA, same idea we had over there. XA equals, keep my notation similar, VAX times T, because I was emphasizing that it stayed the same here. Is that all right?
Yes.
And you can see I'm just kind of like, as I need something, go back, look, try to figure out what it is. Okay. And I've got this number, and I've got time. Hold on.
Interruption. Can I have Kellen Danielson?
Yes. Where does he need to go?
Pardon me?
Where does he need to go? Cut off?
Counseling, please.
Counseling? All right. He's on his way. Are you okay with that in the video?
Yeah.
That's okay? All right, okay. It probably won't be able to be heard very clearly, so.
Okay.
But you're, yeah. All right. I can always bleep it if it bothers you. Tell me later if it does. All right. So XA plus XB equals 6 meters. And I've got XA here. And I know what XA is, which means I can solve for XB. Okay. Let's get XA. So XA is going to be, I'm going to actually put numbers in this time. So let's go ahead and do the 2.33 meters per second times 1.65 seconds And I'm going to grab my calculator so we can get the actual number for my rounding. So 2.33 times 1.65, we'll call it 84. Actually, it's probably 3.85. Let's call it 3.85. Is that okay?
Yeah.
About. Okay, 3.85. And now go ahead and put that in over here. 3.85 meters plus XB equals 6 meters. So we get 2.15. Am I right? Somebody do mental math. I am actually asking that. 2.15? Okay, all right. 2.15 for my XB. Sometimes people think I'm kidding. I'm not. I really want you to check. So 2.15B for XB. 2.15 meters for XB. Is that good? All right, so now I'm going to come back over here. I'm going to go ahead and find this. So we're going to have the 2.15 meters divided by, I feel like there was a way, I could have okay, I just realized something. This is perfectly fine the way I'm doing it, but I could have substituted, look here for a second. Look here for a second. I could have substituted this in here and then solved directly. Do you see that?
Yeah.
I just didn't. I don't know why. Are we good? Is everybody else good? I could have saved a little bit of work. If I had just plugged this in here, I could have solved directly for the V naught BX. Because I didn't really need XB by itself. Is that good? All right. So, but anyway, 2.15 divided by the, what was the time again? I lost it. Where'd it go? Somewhere up here. This is why organization matters. Yeah, right there it is. 1.65 seconds. Right next to me, of course. And then that will get us our V naught BX. And our V naught BX, let's get the number for this one. I feel like I might be able to do that in my head, but let's not. 2.15 divided by 1.65. Yeah, 1.3, I could approximate. So 1.3 meters per second for that. And these circles are not final answers. They're just things I solved for. Is that okay?
Yes.
All right. And remember, we said we could get V naught BY. So physics is now over. I'm going to finish this problem because there's enough math in it, but are you with me to the physics up until now?
Yes.
Where do we have questions from anybody else on the physics before I start just doing a little bit more math? We'd have time for free body diagrams, would be good. Going once, going twice. How many have already found their mistake or the thing they didn't connect to? Already found your mistake or the thing you didn't connect to? Okay, a bunch of you. All right, so I will keep going though. So let's go ahead and pick our equation here. We don't care about V final. So this is the one with the y minus y naught equals V naught t plus 1/2 a t squared. And this will be my V naught by. I'll substitute in 1 meter equals V naught by times my time, which I know, so no quadratic this time, 1.65 minus 4.9 meter per second squared times 1.65 seconds, and that's squared. And this might be cut off on the screen. Hold on, let me go check real quick. If it is, it's not the end of the world. These are just aids. Let's see here. Is it on the screen? I see that it is on the screen, maybe. It's tough to say. Yes, I think so. I think it's on there. There's that column, and there's, yeah, it's on the screen. We're good. All right, and then I can solve this for V naught by. And then we're still not done. Oh, does anybody have V naught by already? Even an approximate value will be good. I'm going to use theirs. Let's see here. V naught by, we'll call it approximately. When did they solve for V naught by? They didn't label it, did they? What did you guys get? V naught by. 8 point. We'll call it 8.7. This should work out to 8.7 meters per second. Is that all right that you can do that math?
Yeah.
All right. So now the last thing we have to do here is put the x and the y together so we can get the magnitude of V naught by and the direction. So this is the tail and tip stuff. So I'm going to draw my x component, which is right here. So I'm going to have an arrow to the right at 1.3 meters per second. Arrow to the right. And this is positive, so not to the right. I caught it before you guys did. Which way is clown B fired? To the left. All right. So this should be to the left at 1.3 meters per second. So I need to go back here and fix this. When I solved here, I got XA plus XP. I was doing these as distances. I need to add the sign here to my, and if this is a distance over time, I need to add the sign to my velocity. Are you okay that it's going to the left?
Yeah.
Okay. If you left that off and you did it correctly at the end, you'd be okay. 1.3 meters per second to the left, and then 8.7 meters per second up. go. And now to add these two, you go from tail to tip. So we go like that, and that'll be my V naught B, and that'll be my magnitude, and there will be my theta. Okay? So for the theta, take inverse tan of 8.7 over 1.3. I'm going to go ahead and do that. So inverse tan of 8.7 over 3. Oops. Second, tan, there we go. 8.7 divided by 1.3. And I'm getting 81 degrees. Let's see what they got. 81.5, yep, I got 81.5 degrees. Yeah, close enough. Yep, depends on the rounding. Also, this time, I didn't use my numbers. I just got their answer, I was being lazy. Okay, so 81.5 degrees. And then for my V naught B, the magnitude, and I got the picture there, so you don't have to say like that many degrees north of west or anything like that. If you've got the, not that it's north and west here, right? It would be that many degrees above the horizontal. If you got the picture, that covers the words, okay? And then for the Pythagorean theorem stuff, 8.7 squared plus, what is it, 1.3 squared, take that to the half power, and we get 8.79 meters per second. And you might be saying, that's really, really close to the y component. And yeah, of course it is, because I did not draw this to scale. If you drew this to scale, the y component would be like about 8 times bigger, right, than the x component. So you'd get something like that. And then as a result, the hypotenuse would be very similar to that side. Is that okay too? All right, not drawn to scale on the board. Let me get rid of that ugly picture. Where do we have questions? Okay, we'll just call this the left side of the board, the middle of the board, the right side of the board. So just picture that as like 3 different sections. Maybe I'll get a colored marker out. I don't think I have one handy. Yeah, I don't have one handy. So where do we have questions? Or re-explain. Left side of the board, right side of the board, middle. Are you good? All right. Where'd the wheels fall off? Was it not realizing something like this?
Yeah.
Okay. Some sort of connection between the two? Anybody else? How many people, was it just like algebra? You just goofed on your algebra. Anybody just messed up your algebra? Okay, it happens. That's the kind of mistake you don't have to worry as much about, because this is modeling a free response question. All right, going once, going twice. All right, done. Let me kill this. Let's see, is it still recording? 22 minutes, that was long. This has a